All right, this is fractions and decimals, section 5.5, and it starts on page 401. And it's just learning how to change a fraction to a decimal and a decimal back to a fraction. It's pretty basic. If you have something like 15/48, the first step you should do is simplify this if you can to get it down to something a little more reasonable. So we noticed we could divide both 15 and 48 by 3 and get it down to 5/16. That fraction bar just means division. So we're going to take the 5 and we're going to divide it by 16. Both whole numbers, and so we know we're going to add a decimal to the right of the 5 and add a couple of zeros. Move the decimal up to the top to our answer area, and then we're going to start dividing. So 16 goes into 50 3 times. 3 times 16 is 48. We subtract the 48 from the 50, we get a 2. We pull down the next 0. 16 goes into 20 once. We subtract 16 from the 20 and we get a 4. We pull down the next 0. 16, or excuse me, we add a 0 to pull down. 16 goes into 40 twice. 16 times that is 32. We have an 8 left over. We add another 0 and pull that down. See how I keep adding zeros until I'm done? And then 16 goes into 85 times. 5 times 16 is 80, and we're done. So the answer is 0.3125, or 3,125 10,000ths. So the point of this was to show that you could do the division and keep adding zeros and keep going until it terminates. That means there's no more to divide. It's done. And you'll practice that. You'll just do the division. If you have a mixed number like 3 and 7/20, just hold on to that 3 and do the division on the 7 divided by 20. So we're going to add a couple zeros after our 7, put that decimal in the answer position, and then 20 goes into 73 times. Subtract 60, get a 5, or excuse me, a 10, and then pull down the 0, and then 20 goes into 105 times. My brain jumped to the 5 before. So we have 0.35 for the 7/20. Then what you need to do is remember to add that whole back in, so it's actually 3.35 because it's 3 wholes and then 0.35. So that's how you change mixed numbers to decimals. A repeating decimal will occur if you have something like 1/12. You would divide the 1 by 12. We're going to add a few zeros after the 1. 12 does not go into the 10, so we put a 0 there. The 12 goes into 100 8 times. 8 times 12 is 96. We subtract that, we get a 4. We pull down the 0. 12 goes into 43 times. We subtract 36, and notice we get another 4. If we pulled down a 0, it would keep going into it 3 times. So that's called a repeating decimal. That 3 repeats. So your final answer would be 0.083, and you put a repeater bar over the 3 to show that the 3 is repeating into infinity. All right. You could also write it 0.083 ... That's an ellipsis, and that shows infinity, and that just shows that the 3 goes into infinity. All right. Actually, I think though you'd want to do 2 3s after it to do ... so it shows that it's the 3 repeating and not the 8 3. All right. Always put your repeater bar over the number or numbers that will be repeating, and they give some examples of that on page 403 and 404. You can have more than one number repeating. So if it was like 0.145, you would write it as 0.145 with a repeater bar all over the 145. Okay. If it was 2747474, you would write 0.274 and put a repeater bar over just the 7 4. So 0.274 and put a repeater bar just over the 7 and the 4, because you're indicating to the reader that the 7 4 is repeating itself. Okay. Remember, if you have negative numbers, the answer still, it's a negative fraction. It changes it to a negative decimal. So you can do that also. So that was that section. It was pretty quick. You're just doing the division, and you either it terminates, you add enough zeros that it terminates, or it will repeat, or you'll be asked to round it, so you're able to stop there. But most likely it's either going to terminate or repeat, or it will, because it's a fraction and a rational number. All right, I think that's it for 5-5.